Hello,
It's
everyone.
live.
This time for sure. My name is Michael Goff, and I'm Principal Product Marketing here at Revenera. And I'd like to welcome you to today's webcast, OSS Management Use Cases for Software Supply Chain Security. Today, we'll be joined by my colleague, Alex Ryback. He's Senior Product Management Director here at Revenera, and he's going to walk us through 4 key open source software management use cases that enable you to confidently identify security vulnerabilities in open source and third-party components within your code, as well as manage OSS license compliance and build a software bill of materials. Before we get started, though, let's go over a few housekeeping details. First, today's discussion will be roughly 45 minutes long, and if you have any questions or comments along the way, please feel free to add them in the Q&A tab, and we'll try to answer those as we go along or at the end if time allows. And if we don't get to your questions, rest assured we will follow up with you individually after the event. We do have a number of resources available that build on today's topic, so please be sure to check those out in the handouts tab, and you can download the ones that look interesting to you. Finally, we will be sending you a link to the recording in the next 48 hours. So with that, let's get started. Alex?
All right, thank you, Michael. One other tip is I'll be showing some screens during the demo that may be a little small, so you do have a maximize button in the top right of the video feed. So if it's too small, go ahead and fill up the full screen so you can see what I'm showing. Okay, so as Michael mentioned, I am part of the Revenera product team. I've been in the open source space for about 18 years. And today's webinar is going to be a little bit different. We're going to kind of do this in 4 parts. So I want to really quickly touch upon where we are as an industry, some of the regulations that are out there that are driving a lot of the work that our customers do. A real quick, not even so much of an SCA overview as kind of key topics for those that may be new to this. So we'll talk about SBOMs, talk about vulnerability reports. I want to focus a little bit on what drives people to use software composition analysis tools and what the different use cases are. And then that will set the context for the various demos that I'm going to show. And then we'll get into the products, take a look at how developers would engage, what product teams would do, how legal and security folks would engage, and get a sense of some suggested flows on how to do this type of work. If there are any questions, go ahead and please post them into the chat, and we'll be more than happy to address them. Okay, so let's start with kind of where we are as an industry. And there's, SCA is one of the most dynamic industries I've been part of. There's lots of different solutions, lots of vendors, lots of activity, lots of regulations brewing. So there's a lot to keep track of. So I always like to start with kind of a single slide to try to boil down what's driving all of the changes and what do people need to look out for to make sure that their programs are up to date. So there's really kind of 4 elements to summarize where we are as an industry today. So first of all, open source use continues to grow and grow significantly. We see developers leveraging open source to speed up time to market, drive innovation, and ultimately it's a competitive issue if you are not leveraging open source and your competitors are, because you're just going to be much slower to deliver value to your customers. We have an audit services team at Revenera that does lots of audit work on behalf of our customers, and every year we look at the metrics of what they put through the system. And back in 2023, we're up to about 3,500 pieces of open source per application that we look at. So effectively, we've gone from low hundreds about 10 years ago to now we're up to about 3,500 average items, which means we continue to see use. The fact that there's lots of AI tools to suggest content for developers. We fully expect that number to grow significantly over the next couple of years. Along with that, we're really seeing security exploits continue to rise, and it's not just in volume, right? There's a lot of vulnerability exploits, but also in sophistication, right? It's no longer a person sitting in a garage trying to hack your products. There's lots of investment. There's foreign actors. There's entire organizations that have very sophisticated attack vectors. There's vectors such as supply chain attacks, where some code may be injected into your development stream and actually be exploited much further along the life cycle of your product. So it's no longer kind of a trivial task to try to identify vulnerabilities and understand all the potential exploits that your product may expose to your customers. So important that you have the proper tools in place to be able to track this and manage the risk. From a mandate perspective, there are lots of different regulations. There's kind of overarching regulations in the US and the Cyber Executive Order. There's regulations in Europe around the Cyber Resilience Act. There's lots of worldwide regulations in different countries, as well as industry specific. So the financial industry, medical, transportation, energy, anything that could essentially cause harm to anybody has some sort of regulations around cybersecurity best practices. Furthermore, if you are selling into the public sector, there's government regulations. If you are a publicly traded company, there's regulations on disclosing any sort of material security issues. And this is something that came into force late last year in December. So lots of different drivers on why this is a hot topic in the industry today. And the reason that this is difficult is, unlike hardware, where if there's an issue with an airplane or a car or a complex piece of machinery, typically that company has an ERP system in place and they can unwind their supply chain and understand which supplier produced and manufactured a part. In software, it's a difficult task. It's a very disconnected supply chain. There's not a lot of transparency in the provenance of parts and understanding who supplied what and which code you're ultimately using and whom do you need to go back to get a fix. And at the end of the day, you're responsible for what you host or distribute. So it's important that you understand the risk that you may be passing on to your customers. So let's talk about security. And this is a very kind of high level overview. We actually have another webinar that you can find on revenera.com where we kind of went through SCA basics. So we talked about security a lot more there. But I do want to talk about kind of the diagram on the right? So when you're talking about application security, and we're not talking about whole company security, we're talking about how do you secure a product or an application. There's really three elements to it, three main tasks that you need to make sure your teams are doing. So first of all, you need to make sure you have a proper framework in place. So talk to your CISO, talk to your security teams, make sure that you are not doing this arbitrarily or ad hoc, that you have a governance framework in place. But also you need to make sure that you are doing three types of security testing that are really important. So SAS stands for Static Application Security Testing, and it effectively tests the code that your developers write. DAST is dynamic testing, and it tests your application at runtime. It's an automated technique to make sure that there are no vulnerabilities or exploits that could be invoked on your product as it is running in runtime. And then SCA at the bottom is critical to understand what risk you may be incurring by using somebody else's code. So your third-party dependencies, your direct and transit dependencies, and what risks they bring into the system. You need to do all three, right? You need to make sure that your developers are doing the right thing. You need to make sure that you account for everything that your developers didn't write. And you need to make sure that when your product is running, that it is secure for your customers. And then pen tests kind of wrap all of this with a more manual testing technique to make sure that the entire ecosystem is secure. So ensure that you have conversations with your teams, make sure that you understand what tools you're using, and make sure that all this information ultimately rolls up into a unified security dashboard so you are able to manage all of your risks. So let's talk about a software bill of materials. So this is going to be important because every piece of regulation ultimately touches on how do we provide more transparency to mitigate legal and security risk. So a software bill of material, you could think of it as an ingredients label for your software applications. So it includes a listing of all of the parts that make up your product, whether these are open source or commercial third-party components. But ultimately, if you are going to enumerate everything that has gone into building your product, your software bill of material is an industry standard format. It's machine readable, and it includes details about each part, the relationships between the parts. So understanding that part B is there because part A relies on part B. And it lists out all of the versions for each part, which is critical because along with an SBOM, you need to understand, well, what is the security posture of an application at a given point in time? So if you look at the definition of SBOMs, and there's a link on the bottom left here when we share the slides, CISA is the US Cybersecurity Agency, and they have lots of great resources around software bill of material. So definitely check that out. They have a lot of papers for different personas from their perspective on what do you do if you're an executive, what do you do if you're an engineering, product management, release, and so forth. So lots of great content there. But if you look at a bill of material, effectively it consumes four things. It looks at all the executables in an application. It accounts for all the commercial libraries. It accounts for all the proprietary software that you wrote. and all the open source dependencies that your product relies on. And what is included in the software bill of material is information about the supplier, so about you, information about who and which components and versions are part of your application, the dependency relationships across the components, who the authors are, ideally information about the licenses that govern the use, and there is an associated set of reports that will list out the security vulnerabilities for all of the parts. Now, one thing that's important to understand is your bill of material is static until you change your product, right? So unless you modify your code, your product composition will not change. However, the security posture of your application is fully dynamic and changes all the time. So typically, you don't want to commingle your enumeration of your parts and your security vulnerabilities in one document. These are things you want to keep separate and keep your vulnerability reports updated so that you understand the security risk at any given point in time. Now, the way that we do this is through security reports. And security reports, think of it as kind of a document that is related to your bill of material. So one such report is the Vulnerability Exploitation Exchange, and VEX for short. And it is used to communicate out of all the security vulnerabilities related to the parts in your product, which ones are the most critical, which ones actually are deemed to be exploitable by your team because you know your product best, and which ones do your customers really need to focus on. So if we look at a picture that explains this concept, so we have the bill of material, as I mentioned, it is static between releases, and it contains components from whatever ecosystem is relevant to the type of product that you're building. So it could be Java, it could be C++, it could be JavaScript. So it just depends on what your product requires for its functionality. And then if you look at the vulnerabilities that are out there, right, this is number one, a moving target, right? The list of vulnerabilities change all the time. But also there are kind of a universe of vulnerabilities from lots of different security data sources. And if you intersect the two, then you get the intersection that really shows you which vulnerabilities are related to the components that are in use in your product, right? So that gives you the universe of what is possible to exploit in your product. And then what VEX does is it essentially color codes that intersection with things that pose risk to your product and things that don't, right? So it is a way for you to assess whether a known security vulnerability in your product actually poses a threat and communicate that to your customers or your downstream partners in a machine readable file that is referenced to your bill of material. So the vulnerabilities are referenced to the parts. It has vulnerability information about it. It has any sort of annotation. So is this a real issue? If so, what is the problem? How do you work around it? How do you mitigate? Or why do you believe it is a false positive and doesn't impact the use of your product? And ultimately, it's a great tool to prioritize your analysis and remediation work to focus on things that are real problems. So we'll get back to these two concepts during the demo. So the next thing I want to focus on is why do people use SCA tools, right? Why is this done? Why is there an issue with supply chain security? So there's really 4 use cases that really drive people to perform software composition analysis tasks. So the first is an inbound assessment use case. So anytime that you have something coming into your company, there is a best practice to make sure that you understand and kind of quantify the risk that you're incurring by pulling that in. So this could be an M&A, it could be a divestiture, it could be a developer wanting to pull in a large library and you want to understand what's inside there, or perhaps you have worked with an upstream partner or a contract developer and you want to understand what's in their code before you integrate it into your company's code base. So this is one of the more common use cases, and it is a proactive case to mitigate risk further down in the process. The second use case is what really used to drive a lot of what was happening is internal compliance checks. So this is typically part of your shift left strategy, and the idea is that the earlier you find out about an issue, the easier and the cheaper it is to address that issue, right? If you don't look for things till many months after the code has been developed, perhaps the developer left, perhaps they forgot about it, perhaps there's been a change in your composition of your team. So the sooner you can get back to the person that created a compliance issue, the easier it is for them to address it. So SCA fits nicely into this use case. It is typically integrated into the development environment that is used by developers, so into your IDE. usually integrated as part of your build pipeline, as part of your CI/CD process. And again, the idea is to have a continuous flow of information going back to engineering every time they do a build, every time they check in code, to understand what risks may be happening, and they can be addressed right away. And from a lot of our customers, typically there would be a feed from this activity into other security tools or security dashboards, so that all of the different testing activities that we covered earlier ultimately flow into a single view. Third use case is really what is starting to take over the internal compliance check, which is industry and customer demands, right? So now it is an external forcing function that says that if you want to do business in this industry, there are certain rules that you have to abide by. So this is what really drives the creation of software bill of materials and accompanying security reports, as well as other reports like third-party notices, and we'll look at how we do that, which comply with open source license requirements. So anything that is to be shared along with your product to your customers or downstream partners is typically driven by either your commercial contract with your customer and or industry regulations into whatever industry you sell into. And then the fourth use case, this is the reactive case, is something went wrong, right? There could be an industry event, so Log4j a couple years back, or any other vulnerability that has been publicized in the news, and ultimately you now have a reactive hunt for toxic code or toxic components or applications. Are we impacted by a particular vulnerability? Or maybe a component went through a licensing change, and maybe that license is incompatible with your corporate policy. So how do you address it? How do you identify where you're impacted? And how do you remediate to make sure that you are not blocked from upgrading components and in turn incur a security issue, right? So this is more of, if you haven't done the three on top, now you're kind of on your heels trying to catch up. If you've done the work, then it should be as simple as querying your system and understanding where a particular component, license, or vulnerability impacts you across your organization. Okay, so everything that is highlighted in green here is kind of the context under which we're going to look at the use cases and the various demos. So here are the key demos that we want to focus on today. So the first one is a dependency assessment, and this is really targeting your development team. So think of a developer running a local smoke test before they check in any code to ensure that all of the dependencies that have been brought into their project are compliant with your corporate policies. So making sure that there's no licenses that are on the do not allow list or on a requires additional work list, and making sure that all the security vulnerabilities that come along with direct and transitive dependencies are visualized, assessed, and understood, and agreed to be okay to continue the work, right? So it's an early indicator as part of the shift left process that there is a problem that can be addressed immediately. Usually this use case is assessed locally, right? When we run our IDE plugin, nothing gets persisted, nothing gets sent back to the server. It's for the developer's benefit to get insight and make the change before they check in code. The second use case really addresses benefits to both sales and compliance teams, because this is a use case that potentially could cause friction in the sales cycle. So as you sell software into various industries, you're going to be expected to provide an attestation that you are following best practices. And in some cases, you may be asked to provide a software bill of material to your customers that gives them transparency into what it is that they're buying. So this is a use case that comprises both the dependency assessment, any sort of CI/CD integrated scans, as well as potentially having a team of specialists that do a deeper dive and make sure that your bill of material is complete and accurate. And we'll talk about how to do that. Third use case, third-party notices. So as I mentioned, SBOM typically satisfies the needs of what your customers want to see for transparency. Third-party notices satisfies one of the most common open source license obligations, which is to provide attribution or give credit to those whose code you're using for your benefit. So our system supports preparation of third-party notices, and we will look through how to do this. Ultimately, this hits the legal and our compliance team to make sure that you are properly using the open source licenses that govern the components that you need for your product to function. The fourth one, security assessment, right? So now we're talking about, we now have looked at what is inside of our software. We have a list of components and versions. We now have a list of vulnerabilities reported from multiple data sources. Which ones do we need to pay attention to? Which ones do we want to annotate and or suppress? And this will drive the generation of your VEX report to be able to pass on to your customers so that they can understand what it is in your product that ultimately may be impacting their use of your application. And then the final use case, which kind of cuts across all of this, is the reactive use case, right? It's the impact analysis. So what if something went wrong? What if a customer reports an issue? What if a security researcher interacts with your PCERT team, right, and reports a security problem that they found? Or what if in the news there is a highly used open source component that has a nasty new vulnerability? How do you understand? Does it impact you? Where does it impact you? And where are you in your remediation process? So we'll take a look at all 5 of these. Before we jump into the demo, I do want to talk a little bit about process, because I always get questions on, this is great, but how do we actually do this? How do you set up your development team with the legal security, and how do you kind of run through all these flows? So the thing that I typically recommend when we start with somebody is a 2-phase process. Now, this is not by any means the only way to do it. To me, this makes the most sense because you are not blocking engineering teams from being productive. And if you have the benefit of having some specialists at your disposal, or partners, or you purchase services from your SCA vendor, then that's something that they can help with and make sure that your SBOM is complete and accurate. So the first phase is kind of an engineering flow, right? So everything starts with the product teams or the developers, and we will look at the plugin demo, and this is where, again, developer gets information immediately as they're working in their IDE, and this does not require performing a build, does not require uploading any code for scanning. The next thing that happens is, as part of their build process, there's an automated loop. So the build process will invoke a scan plugin. So our system includes remote scan plugins that will operate and do remote scans in your build system, in your container server or Docker server, on the remote machines and so forth. So the idea is you do a build, it'll invoke a local scan, and then the information goes into a team or into a project managed by your product team. If there's anything against your policy, then there are automatic JIRAs that can be created that go back into development backlog, and developers will then schedule and prioritize their remediation work based on these JIRA issues that are created. So this is the first phase, which is a continuous compliance check loop, right? And the idea here is that this does not require anybody to remember to push a button or anybody to remember on a process. This is something that should be running fully automated as part of your DevOps pipelines. And it should be fully integrated to the systems that you use to give engineers visibility as soon as the build is completed if there are any issues with the snapshot of code that they just built. The second loop comes in is your SBOM refresh. Now, there are lots of companies that are further along kind of on the maturity curve, and they would combine this into one process, which is great, right? The end goal is to have everything be continuously automated. But reality, when you're starting out, you want to get engineering scanning, you want to get them scanning often, and you want to get them visualizing any legal or security issues that come out. But that is not always going to yield you a complete and accurate SBOM. So that's where you would have folks from your open source program office, perhaps analysts, maybe services team partners, come in and do a deeper dive on the code base. Typically, this is done at a lower frequency, so maybe one, for each release. Perhaps you do it weekly or monthly, whatever makes sense to your release cycle. But this ensures that whatever bill of material you have is complete and accurate, and it becomes an incremental exercise going forward. Now, notice all these arrows ultimately point into the same product, same database, out of which come all your compliance artifacts and your bill of materials to ensure that you are complying with industry regulations and providing what you need to customers. And then as far as the demos we talked about, so dependency assessment is in this context. Your impact analysis and security assessment is happening on the aggregated set of data, and the artifacts that are generated by the system satisfy your third-party notice requirement and address your SBOM construction. So that's the lens through which we will look at the demos. And then finally, let's talk about how we build a bill of material with our project, Revenera SCA. So our system scans all files, not just source. So we're agnostic to files. So images, icons, binary, object code, whatever is part of your code base, we will scan. And depending on the type of file that we encounter, we will perform different functions for that type of file. So our purpose for the product is to build your software bill of material, right? That's kind of the core function of the application, is to make sure that we inventory all the parts that make up your application. Once we do that, we can then report legal and security information to determine if those parts are compliant or not. So the first thing that happens, and we talked about it in the previous slide, is the automated discovery portion. So this is something that is either done in the context of an IDE or as part of your build or as part of a code base upload or sync with your source management system. And it's done completely automated, right? No humans required in the process. This is when we run various techniques to automatically construct as much of the bill of material as possible. So we will look at various repositories. We've got manifest file parsers and scanners. We've got various rules for specific components that may not be managed through package managers, specific files, and so forth. So this will construct your bill of material given all the information available in the code base without any human intervention. The second part, and this is something that makes our offering unique, is at a file level beyond the automated bill of material, we will provide you evidence of open source and third-party and commercial content. So things like what are all the copyrights, email URLs, the licenses discovered at a file level, search terms, so borrowed from, stolen from, inspired by, right? Those types of things. So anything that screams out that this is not code that you wrote. We also are able to do things like exact file matches, source snippets. I see there's a question there around C, C++. Yes, we do scan all programming languages, whether or not there's package manager support for those ecosystems. And in many cases, if you look at older applications that are written in C, C++, you may not have a package manager in place. You may not have manifest files to rely on. So the analysis on the right, the evidence of open source, becomes a really important technique. And then third is manual disclosures or an import, right? There may be cases where you are using somebody's SDK or you have a contract developer and they basically gave you a spreadsheet or a text file or maybe an SBOM of what is inside their application. You don't have access to scan their code, right? But you may want to import that disclosure in to run alongside of what you are discovering as part of your process. So those three techniques, so the automated part, the evidence of open source at a file level, and then the import or manual disclosures ultimately ends up in you being able to build a complete and accurate SBOM. And then the system is designed to learn over time, and everything is incremental and reusable. So the more work you do in the system, the less work you do as you use it over time. Okay, and to the question, right, there's a link here that you'll get in the slides to the supported ecosystems as part of our solution. So if there's any questions around which languages, which file types, so forth, that is all listed out in the ecosystems documentation. Okay, so let me pop out of the slides here and let's jump into the product. Okay, so the first thing I want to do is I want to focus on the IDE use case, right? So you are a developer, you are writing code, right? You're ready to commit your code that you've written, and you want to do essentially a smoke test to make sure that whatever dependencies are in your application today are represented in the dependency tree, and you want to get a sense of if there are any sort of license or security issues associated with those dependencies. So if we look at the way that this works is we have a plugin called OSS Inspector. So it's a new plugin that we will be releasing shortly. And it allows a developer to essentially run a Java or Kotlin build inside their IDE and understand their dependency tree, and then use our data to look up the licenses and vulnerabilities associated with those components. So let me go ahead and kick it off. And while it is running, so it should take a few seconds to a minute to run, let me talk about how it's configured. So this is fairly straightforward. Once you are onboarded as a customer, you would then come in and you would generate a token for yourself. And all you really need to do to configure the system is just add in your refresh token that allows you to communicate with our database through our APIs. Nothing that you do here is ultimately persisting anything. Nothing is interacting with our Code Insight application. That is something that runs on-prem. All of this is done locally on the developer's machine. So you can see here, there is a list of modules that have been discovered as part of analyzing this project. There are scopes for each module, and then there's a dependency tree provided for the various scopes. And if you click on a particular dependency, then on the right, we will tell you the licenses that you have there for that particular component. You get a link to the project website. You get a package URL for the component that was discovered, and you get a list of associated vulnerabilities with their severities and scores. So this is a new offering that we have. So there's a rich roadmap to further improve this offering here. But at the moment, this gives developers an immediate visibility into, well, this component has vulnerabilities. One of them happens to be a high severity. If you want to research it, you just click on the vulnerability. We'll take you to NBD or whatever data source that vulnerability was reported by, and that will give you additional information about that particular vulnerability. Okay, so that's the IDE use case. And again, it's fully independent. Nothing gets saved, nothing gets persisted. It's just for the developer's benefit of understanding if they have an issue or not. Second use case, so let's look at a build. So here's a Jenkins instance. I have a Jenkins project configured here. So let me go in, I'll kick off a build, and while the build's running, let me kind of walk you through how it is that we configure the plugin. So very similarly here, we install a plugin in Jenkins, and ultimately all you really need to do is you need to pass it a URL to the server. You need to give it a project name, right? Which project is this build for? And you give it an alias, because when you look at our projects, we have multiple scan routes that we support, and each one needs a unique name. So whatever alias you provide here is what you'll see as the root of the scan inside Code Insight when you're looking at the results. You also have an option as part of after the scan to generate a report on the server and then stash it as part of your build, right? So this gives your build team and your product team indication of how they look in the particular build. So let me open that. So here's an example of our inventory report. So scanning the code base of the build, you can see a license summary, you see a vulnerability summary with counts, severities, and you can see an enumeration of all the parts that were discovered. So you get the component, you get version, you get license information, you get a list of vulnerabilities, and you get a column for compliance issues, right? And a lot of these things are configurable. So you get a sense for what it is that's causing this item not to be green, right? So it could be that it hasn't been reviewed yet. It could be that there's a vulnerability. It could be there's an unknown license. It could be that you have an old version, right? So for example, here, if you mouse over it, it'll tell you how far back you are from the latest version available on that repository. So this is a great way to have that first loop, the automated compliance check in the system, where with each build, you get a compliance report. This is something that can be compared build to build, and you get a sense of what it is that's potentially causing compliance problems for you, so they can be addressed as soon as possible. Okay, so now we've acted as a developer. We've done this as a build team. Now let's jump into the product and see what this looks like for the data that's been persisted. So our product is Code Insight. It is a task and role-based system, right? So depending on who you are, whether you're legal or security or a developer or just an observer, you will be able to see different links. The way that the system's set up is there's two main views. There is a global view of everything that's been done across your organization, and then there is a project-based view. So let's start with the project-based view. So the project-based view gives you a list of all of your projects, right? And a project could be an application, it could be a module, it could be an arbitrary bag of files, it could be some piece of code that's been written outside your company. So it's whatever you want to encapsulate in a single code base, essentially. We do support linking projects together, so we do have project hierarchy. So for example, here, if you look at my application, let me real quickly jump to one of the reports for it, and you will be able to see, let me open this one. So same report we had, right? You can see here there's a structure to it. So you have an application, you've got a core server, you've got a scan server, you've got an analyzer project under there. So here we got 3 layers of hierarchy. And ultimately, the reason we do this is whenever you build your product, you're likely not modifying code in every single module. So there's no sense in having to redo all the work. So if you are able to break your project up into modules, and maybe you have multiple development teams responsible for one application, the way that our system is designed, it allows you to only focus on the modules that have had code churn, have any sort of compliance issues, and then ultimately you would just go back to the top level, rerun your reports, and everything will get rolled up to the top, right? So it's designed to require you to do the least amount of work. Now, going back to project view. So when you click on a project, right, we give you a dashboard to understand what is your security vulnerability exposure, what is your license exposure, what is the calculated priority of the inventory item based on a combination of license and security, and where are you as part of your review status. And there are rules in the system that we call policies that you are able to configure based on licenses, components, version ranges, vulnerabilities to automate the review process. So the idea being that after a scan, you look at kind of what's red, yellow, green, and the job is to get the red out, right? Get rid of the red or accept the red as something that you are comfortable with. Okay. So when we're talking about building an SBOM, so first of all, we had just run a Jenkins build and a Jenkins scan. Let's look at how that manifests itself in the product. So this is a view that we call analysis workbench. This is essentially an analyst view into everything that's going on. So everything that's been scanned and your running list of your bill of material items. You'll see everything with a solid dot are items that are included in your SBOM. Everything with an empty dot are items that are either work in progress or false positives or ones you don't want to include in your bill of material. So you have control over what gets published and what doesn't. You can see we did Jenkins build number 2, that was the alias, and you can see the code base that was ultimately scanned. We can go ahead and filter it, and on the right you'll see that we now reduce to just the parts that came in through this Jenkins build. So your project could be a combination of multiple builds. If you have a multi-phase build, it could be multiple modules, could be multiple projects, could be a combination of code that is either synced through source management, uploaded into the system, as well as automatically scanned on a remote server. So everything comes together, gets normalized, reconciled, and you end up with a single list of your bill of material items. So let's go back to application level and let's look at the resulting SBOMs. So if we go to our reports, you can see we got 3 different SBOM reports. We have a human readable HTML and Excel report, we have an SPDX report, and we have a CycloneDX report. So human readable gives you 2 options. There's an HTML view and an Excel view. And you can choose whether you want to include a column around whether there are security vulnerabilities associated with any given part. You see here that there's multiple projects, so we flatten out the view, but this includes as a report option. You can choose if you want to do this or not, but it either includes just the project you selected or rolls up everything through the child projects up to the top level. Okay, so this is the human readable view. SPDX, exact same thing, but it's going to be an SPDX JSON format. And then CycloneDX is the 3rd format, and that, again, same thing in a JSON format, but in the CycloneDX structure, so it could be shared with customers and automatically parsed. Right, so that's how we deal with SBOMs. Next up is what do we do around license compliance? So let's talk about third-party notices. So if I go back to that same project that I was in, so my application, and if I go back to the workbench view, I'm sorry, if I go to the project and inventory view, so this is everything that's been published to be included in the software bill of material. So for example, let's say I want to look at things that have critical vulnerabilities, right? We have an advanced search here that allows you to slice and dice and really whittle down your list of SBOM parts by lots of different categories. So it could be filtering by vulnerabilities, filtering by licenses, by review status, by priority. We even have options around dependency scopes and dependencies in general. So maybe I want to look at only top items, only direct dependencies, translate dependencies, so forth. We also have an ability to have custom fields. So if you want to add any sort of custom data beyond what we support in our data model, those fields are also available to use as part of your search. So if I apply the filter, you'll see that I'm now reduced to 4 out of 60 parts. So let's go ahead and click on this bundler item, right? So we have this item that is an SBOM part. It is called bundler, version is 1.15, and it's under the MIT license. So the first view we get is kind of a description of what this thing is, right? So we've got the package URL. You can see who created it, when it was updated. You can see the provenance, right? So this came from another project, perhaps. It'll tell you the provenance in your scans of where this item came from. Then you can see information about the associated component. So bundler happens to be a Ruby gem package. You get the component information, version, the possible licenses, because there may be more than one, the selected license, and vulnerability information. You'll notice here there's a tab for notices text. So here you can see there's two fields here. There is notices text, which is license information that is found in the scans, so in the files associated with this item, and that is populated for you based on the scan. But we also have this notices text field that allows us to pull notices text from our repository of third-party notice data. So you can see we started an empty field, and now we pulled in the actual MIT license, not the template, that has the copyrights and dates for that particular component version. So this is the task that if you don't have a system like this, will typically take whoever is responsible for preparing your notices a long time, because they have to go out and research every single component to make sure that they have the proper license text. In our system, with a click of a button, and in fact, it happens automatically during a scan, we will populate all the notice text that we have available. And when you run the report will indicate anything that was not populated and not available. So let's go look at the third-party notices report. Again, the report's available in multiple formats. Let's look at the HTML version. Here it has a list of all the components that are part of your product. And then under the components, we have an enumeration of license text. So you'll see there's a couple here that say text not available. That means that that's something that has to be manually done. But you'll see a lot of these are automatically populated for you. So the MIT license, anything that is a common license is in the appendix, so we don't have to repeat it over and over again. And each component is linked to that reference license. Okay, so now that we have done third-party notices, we've done the SBOM, let's look at how do you do a security review. So again, I'll go back to my project inventory, go back to the same bundler item, and you'll see along with the component version and license, we also provide a list of security vulnerabilities. So over here, what you can see is an enumeration of all the vulnerabilities associated with bundler version 1.15. So you'll notice there's multiple sources. So we have 6 different data sources we collect from. Here you can see there's RubySec, NVD, GitHub advisories, and so forth that are all coming together in one view. We provide you the vulnerability with a link back to the security data source. We also provide you a description of the vulnerability, its severity, CVSS scores. So a lot of these vulnerabilities will have either CVSS version 2, 3, and we are working on also adding version 4. That will be coming up in 2025. But ultimately, we provide you scoring for both. And there's a system setting on, do you want the system to use version 2 or 3x scoring? So there will be cases in older vulnerabilities where there won't be a CVSS 3 score. In the newer vulnerabilities that are reported, sometimes there won't be a CVSS 2 score. So the way that's handled is when you click on this info bubble, we give you both scores. We also give you a link to the vectors. So if you click through here, we take you into the calculator. So your security team can assess based on how your product is deployed, how it's used, whether the score needs to be increased or decreased based on how your customers actually interact with your product. Beyond that, we provide a common weakness enumeration. So this is a classification of the type of vulnerability it is. And we provide you EPSS scores as an indication of how likely this is to be exploited in the near term. So EPSS is a metric that essentially tells you the likelihood of a particular vulnerability having an active exploit in the near term, in the next month or so. We give you information on when the vulnerability was published, when it was modified, and then there's information pointing you back to patch links. And then finally, we have this analyze capability. So I want to spend some time here. So as part of disclosing to your customers which of your SBOM parts have vulnerabilities and which vulnerabilities matter to them, we have this vulnerability analysis dialog. What this is it conforms to the CycloneDX definition of a vulnerability exploitation report, so a VEX report. And it allows you to define, number one, so you have the component, the version, you have information about the component, and you have information about the state, justification, and response, your team's response to a particular vulnerability. So if you wanted to annotate that something is a false positive because code is not reachable and therefore you won't fix it, or something is a true positive, and perhaps all you have to do is change the default password or default port. This is the way that your security team can communicate to your customers so that they focus their energy on the vulnerabilities that actually matter to how they use your application, whether it's hosted or distributed. You can save this analysis, and you also have an ability to suppress. So if something is bad data, you can globally suppress the vulnerability. If something is a real vulnerability, but perhaps the way your product is used or constructed, that vulnerability is not impacted by your application. Maybe you don't call into the function. Perhaps you have an on-prem application, therefore it's not reachable. But that allows you to suppress it at a project scope, which means for this application, the vulnerability is a false positive. Maybe for another one, it is not a false positive. So your security team has complete control over all of this vulnerability data. Now, how does this reflect itself? Let's go look at the CycloneDX report. And let me go ahead and download the report here. And you will see inside the report, there are a few different outputs. So we have a JSON and XML version of the CycloneDX report. That's the one we looked at previously. We also have a VDR report. So VDR is a listing of every single vulnerability that is across all of the parts that are inside your bill of material. So this is kind of your give me all information about all the potential security issues in place. The VEX report then takes the annotation that we just looked at and puts that into an industry standard parsable format. So this provides your customers information about this bundler component, this particular Ruby sec vulnerability, and the fact that you've annotated that it's not affected, it's not reachable, won't fix, and then whatever details you want to provide about your analysis of that vulnerability, all reference back to the component that is part of your software bill of material. All right, so we go from information being presented to analyzed by your team, and then annotated and generated into a report that you could share with your customers. Okay, the final thing I want to look at is the impact analysis use case, right? So let's say you've been using the system and something goes wrong. All right, let's say either your customer reports a vulnerability or security research reports a vulnerability, or perhaps there's a vulnerability in the news and you want to understand, and it could be a license, right? It doesn't necessarily have to be a security issue, but you want to understand where you're impacted. So for this, we have what we call a global inventory view. So now you can see that we have every single item across the system as part of this view. And we have the exact same search capability as we had at the project level to be able to say, show me everything across all my products, all my applications, could be including your upstream supplier code. I want to see everything that has a particular vulnerability. So here's one I grabbed from 2017. And when you click apply, you'll see that real quickly, we're now down to 14 instances of components that expose you to that vulnerability across 20,000, right? So this is really the payoff for having done the work. If something happens and you're kind of on your heels in a reactive scenario, you don't have to go and talk to every single development team and have them, kind of understand what they're doing and what they're using. If you've scanned all your products, if you have a complete bill of material for all your applications, this is where you're able to come in and quickly answer questions of where are we impacted? Are we using this component? Do we have a particular license in use that's against our policy? Or search by vulnerability to see which components potentially expose you to that vulnerability. Okay. A couple questions, let me answer them while we're here. So do we support SPDX 3.0? We're working on it, both on import as well as generation. Generation will likely come first, but the plan is to support both SPDX 2.x as well as 3.0. Then there's another question on, does Revenera have access to my code base on a remote server? Are there on-site options where we could host our own? So the product I'm showing you now is 100% on-prem solution. Nothing ever comes back to us. Everything is scanned locally, either in your private cloud or in your data center or on a server you set up. And we have ways we can even run air-gapped with no connectivity to the outside world. So it is designed to be fully on-prem and will support not having to share anything with us. No files come to us, no hashes come to us, none of the results come back to us. So fully on-prem. Okay, the final thing I wanted to touch on is how do you get started with this, right? So let's say maybe you're new to this, maybe you have an existing product in place, maybe your team has been starting and struggling and don't know how to go. So here's kind of the simple 3-step process of how to kind of wrap your mind around how to get going. So the first step is make sure that you operate within a security framework, right? Chances are you're not starting from scratch. Your security teams likely have already have something in place. Maybe your teams aren't educated on it. So start by talking to your CISO, your security teams, your engineering management. Understand what frameworks are in place, what are your best practices, what are the tools that you have at your company to perform these functions. Step 2 is work with legal and security to understand, develop, and maintain your policies, right? It's really important for you to have policies. In fact, maybe that's even step number 1, because if you don't know what is the definition of good and bad, how can you manage it? So you need to have policies on how to properly consume open source, both from a legal and security perspective, and make sure these policies are updated over time. And you need to have an understanding that absent known terms of use, you can't just grab the code and use it. You're going to be putting your company at risk. Very often, people are focused on the security side of it, don't really focus too much on the legal side, but it's important to understand you may have a component that changes licenses, and perhaps the new license is not agreeable with your organization. Well, now you're blocked from upgrading, which can in turn cause a security issue. So these two things are intertwined, and it's important to understand that. And then 3, just start generating SBOMs. Likely your customers are asking for them. I know ours are. If you're not asking your customers, if your procurement teams aren't asking your suppliers for SBOMs, you should start. Start creating them. Make sure you create the accompanying security reports. Talk to your customers. Make sure that the SBOMs you're generating are useful to them, providing the information they need. It's a conversation to make sure that the effort you're putting in is benefiting your downstream customers and partners. Okay, with that, let's see if there are any other questions. There's one question around dual licenses. Are there policies to make tool decide which license to report? So there's a couple of different ways to handle it. We have this concept of a license precedent. So if you want to say, between MIT and MPL and LGPL, we prefer MIT, there's a way to tell the system to pick that one. Otherwise, there are rules that you can put into the system to say, for a particular component, we always want to use it under this particular license. So it can either be a human choice or the system can be configured to automatically make that choice for you.
Thanks, Alex. Couple of quick questions. We've got a few minutes left. I know I said 45 minutes originally, but always good stuff. Can you talk a little bit about some of the approaches to structuring the scanning activities?
Sure. So back in the product I had showed, let me jump back into it real quick here. So this view here, right? So this was the kind of the project folder view. So there's several ways people structure this, right? Some companies say we're going to create a folder. So everything in bold here is a project folder. We're going to create a folder per application and throw everything into one project, right? So that's kind of the very basic approach. Others say that, we got multiple teams working on this thing. We don't want each team to have to figure out which subset of files they are responsible for. So we're going to create multiple projects. We're going to link them together. And ultimately, that's kind of the way we have this set up, where analyzer may be one team, core scan server may be another team, and they work independently, but all their work is rolled up to the top, right? So that's another way to do it. We have customers setting this up by product. It could be by geography. It could be by leader. It just depends on how you want to visualize the results of the scans. And ultimately, if you want to interrogate a product or an application or a team, however you structure it will make it easier for you to navigate to the right place.
And one last question for me while we wait, in case anyone has any last questions. How much of this can be automated?
So a large amount, right? If we kind of go back to this slide here, this whole loop, like the first loop, is 100% automated, right? The whole idea here is you don't want to slow down productivity, right? You want your team to be doing their job, which is innovating, building new features, and you want the system to wake up and tell them there's an issue, right? That's fully automated. This part, as requirements mature, as you've done kind of the upfront work and getting to your kind of baseline SBOMs, this becomes a small incremental lift release to release, because typically, maybe you're turning 10 to 15% of your code. You're not going to swap out all your components for each release. So this becomes incremental work. As you do more and more of this, it will take care of more and more of the SBOM. The first time through, there's going to be work, clearly, because again, for some companies, just dealing with dependencies is enough. Depending on what industry you're in, other companies go look at snippets. They go look at images, icons. They look at copy paste. They will look at older languages that don't have package manifest support. So it's important to have a solution that doesn't just focus on reading manifest files, but fully looks at all evidence of open source in your products. The other reason this becomes important is when you look at all of our functionality around file level evidence, you'll often surface conflicts, right? There may be that a component is under a permissive license, but there is a viral license and a single file inside there, and perhaps it's sample code that needs to be stripped out before you release it. So there's lots of these types of inconsistencies that the product will highlight, and you'll get a sense of, do you need kind of legal remediation work to make sure that you're not putting your company at risk.
Great.
Well, and I didn't mention earlier, but there is a REST API for everything I showed. So if people want to automate report generation, getting data in and out of the system, invoking scans, there's a REST API that will allow you to perform everything I showed today, except for the ID analysis that's devised for that product.
Great. Thanks, Alex. And we are just about up on time. So Alex, thank you again. I always learn something new from your webinars. Today was no exception. So thank you for being here. Thank you for sharing that knowledge. And thank you to everyone in the audience for joining us today. We really appreciate you being here. Please be sure to let us know if you have any follow-up questions, things that you think about as you watch the recording, which we'll be sending you the next day or so, or things that you think about as you digest today's presentation. So with that, thank you, Alex. Thank you, everyone in the audience, and have a great day. Take care, everybody.
All right. Thanks, everyone.